Another really important topic in analytical chemistry is calibration curves. Essentially, all a calibration curve is it's a often linear line where you take several measurements of with an analytical method where you know very closely the concentrations or quantities of that specific analyte, and this allows you to be able to measure unknowns based on this calibration curve. So I've used this in my own research to determine the unknown concentration of a transient species. This is what we call a spin trap, where we react a organic molecule with a hydroxyl radical to create this more persistent species.
So the way that we determine the concentration of a radical that we've trapped, we use the calibration curve with this species called Tempol, which is much more stable. So we measure the integrated absorbance at several different concentrations of Tempol and generate this calibration curve so that we can then, if our absorbance of our trapped radical is in this linear region, we can determine the concentration. So this is the method of least squares. Essentially what this does is it draws the best straight line through your experimental data points, and when it says method of least squares, essentially what's happening is they're minimizing the square of the differences between the line and your data points. And you can use the Linest function in Excel for least squares, and that will give out your slope and your intercept along with several other parameters, or you can use the slope and the intercept functions in Excel. So that's how you would do that in Excel. But I just want to do a quick example. Assume that the absorbance for a BMPO OH sample, so this is our transient unknown, is 9 times 10 to the 8th. What is the estimated spin concentration for this sample? Okay, so the way that we would do this is pretty straightforward. So this is our equation for our calibration curve. So we know that the equation for any straight line is y is equal to mx plus b, where m is our slope and b is our intercept. And we know the absorbance, so we're trying to find out this unknown concentration. So we can say that x is equal to y minus b over m. And in this case, y is 9 times 10 to the 8th. B is 1 times 10 to the 7th. And so our slope is 3 times 10 to the 8th. So when we solve for this, we get that x is equal to 2.96 millimolar of our BMPO OH concentration. Alright, so that's just a brief introduction to calibration curves, and I wish we could spend more time on this topic, but we'll do a few more practice problems in class on Monday.